In today's video, I'm going to show you how to find the shortest path between two vertices on a weighted graph using Dijkstra's shortest path algorithm. Here we have a graph where vertices are connected by edges, and each edge has a weight or cost, which you can think of as the distance between the connected vertices. The goal is to find the path from a source vertex to a destination vertex so that the total combined cost is as small as possible. For this, we need to keep track of which vertices are visited and which are not, as well as the currently known shortest distance to every vertex and its predecessor or the vertex from which we arrive to it. We'll initialize the shortest distance to all vertices to infinity, since it's currently unknown, except for the source vertex from which we're starting, and we'll initialize its distance to 0 because we're already there. Now, we start by finding the distance to all neighbors of our source vertex. In this case, those are B and C, because we only need to cross one edge to get to each, so we update their shortest distances and set A as their predecessor. Then, we mark A as visited and pick the current vertex with the shortest distance from the source out of the unvisited vertices, which in this case is B. Now, we essentially repeat the process for B that we did for A. We find the distances from the source to all neighbors of B by adding together the distance from the source to B and the distance from B to the neighbor, and we update the distances for the neighbors. However, we only update each shortest distance if it's actually shorter than the current shortest known distance. In this case, both distances to C and E are better, so we update them and set B as their predecessor. After that, we mark B as visited, and we keep repeating this process until all vertices are visited. So, up next, we need to visit C. Out of C's neighbors, B is already visited, so we skip it, and that leaves us with D. Anything is better than infinity, so we update D's shortest distance and set C as its predecessor. Then we need to visit D, and out of its neighbors, we skip C because it's already visited, and we update the distance to E because we have found a shorter path. E is the last unvisited vertex, and there are no unvisited neighbors to check, so we're done here. Now we have the shortest distance from A to every other vertex, and we can also find the exact shortest path by looking at the predecessors and recursively traversing the graph. That was Dijkstra's algorithm. I hope you learned something new. If yes, then leave a like and let me know in the comments what algorithm you want me to cover next. Also, make sure to subscribe to never miss out on a new video, and I'll see you next time.